Okay, so we're going to look at problem number 33. I can't find my marker. All right, problem number 33 says determine whether the equation defines y as a function of x. My understanding to this problem is they're wanting to know if it is a function or not. It could be a relation, but they want to know if it's a function. For it to be a function, every input value should have only one output value. So if I were to look at 33, 33 says y is equal to 1 over x. The general graph of the function y equals 1 over x, the general graph of it, it's a parent function. The graph looks like something like this. It's going to be in quadrant 1 and quadrant 3. It's going to have a vertical and a horizontal asymptote, which is the x and the y axis. But if you were to use the vertical line test, and if you were to scroll this across, it can only cross in one spot. And as you move this across, you're going to notice it's only going to cross in one spot. Yeah, right there, it might look like it's 2, but it's just not drawn very good. You will have values of 1/100th, 1/99th, 1/98th, 1/97th, 1/96th, and so on as you go. So the same thing here, right there at that particular point, if you put in values for x and you keep letting those values get smaller and smaller and smaller. So if x is 0, you get a vertical asymptote right here. Because if you put in 0 into your equation, you get 1 over 0, which is undefined, and you cannot have that. So it does not exist there, and that's where you get your vertical asymptote. But if you were put in a smaller number, say, let's let x be 1/4. When you put it into your equation, you get 1 over x, which is 1/4. 1 divided by 1/4 means 1 times 4 over 1, and you get a value of 4. Excuse me. If I let it be, let's say 1/9. If you put 1/9 in, 1 divided by 1/9 is 9. So you're here at a 4th. Let me get this out of the way. So here at a 4th, you're going to have 4. Here at a 9th, you're going to have 9. And as you can see, it goes up rapidly or quickly, but they will not, the vertical line test will not fail. They still don't overlap each other. So I would say, yes, this is a function. Easiest way to look is the vertical line test, but it's hard to see because it does appear, as I put that line right here at that 1/9, it kind of looks like it appears to be crossing that graph in more than one spot, but it's not. So the vertical line test, I don't know if she's talked anything about the vertical line test, but for every input, which is your x, you will only have one output, which is the y. So if I were to take a graph, such as a circle, and if I were to do the vertical line test with that, as you can see the vertical line moving across, if I were to move my vertical line right there, this is not a function because I get 2 outputs for 1 input. So that's saying if I take my calculator and if I were to say x is 2, I don't know. Does your calculator give you a value of 2, which is graphed as that top spot on your circle? Or does it say 2, -2, because that's the bottom graph, the bottom spot there on that vertical asymptote line that I have drawn? Or the vertical line test, not asymptote, but the vertical line test. It's that bottom point right there, 2, -2. So your calculator is confused. Do I say the answer is 2 or do I say the answer is -2? That's what does not allow it to be a function. So this is not, but the overall problem 1 over x, yes, that does happen to be a function. Okay, so the next question is on 36. If you look at problem number 36, it says y is equal to plus or minus the square root of 1 minus 2x. If we think for just a moment, the parent function of the square root of x, I know she probably did not talk about graphing, but the general graph of a square root looks something like that. Now, we can manipulate it and we can have the graph turned backwards or something like that. If you negate it, you are negating the y values. Keep in mind, you have to, the radicand value has to be a positive number or you're not going to get any information. So if I just graph the square root of x, the square root of x is, let's plot just a few points. I can't say x is -1 because you take the square root of -1 and you get an error on your calculator. So that does not exist. So I should not have any values over here beyond the vertical axis or beyond y when x is equal to 0. I should not have anything to the left of the y-axis. So if I pick another point, if you pick 1, well, if you pick 0, the square root of 0 is 0. If you pick 1, the square root of 1 is 1. If you pick 4, the square root of 4 is 2. So I get these points at 1, 1. I get a point at 2, 3, 4. I get a value of 2. At 9, you're going to get a value of 3. So your graph curves upward and does something like that. I didn't plot them very well, but your graph curves like that. Now what happens when you say plus or minus is if I take this table and I now put that minus sign in there, y is equal to plus or minus x. If I deal with that negative, I'm still going to get an error at -1 because you can't take square root of -1. The negative is in front of the radical sign. If you put 0 in, you're going to get negative the square root of 0. The square root of 0 is 0. The negative in front of it makes it -0. 0 is neither positive nor negative, so you get 0 again. If you put 1 in, you're going to get the opposite of the square root of 1, which is -1. If you put 4 in, you get the opposite of the square root of 4, which is -2. That means your graph's going to do something like this. Going back to the concept of the vertical line test, if I were to move this vertical line across, it crosses your graph in 2 places. And therefore, that is not a function. Think of it this way, something she might have said. It says for every input, you only have 1 output in order for this to be a function. All right, so let's pick a number. Let's pick 1. I'm trying to think of something here. Let's pick 4. No, not 4/2. Let's go ahead and pick, let x be 1/2. So if x is 1/2, your y value is going to be plus or minus the square root of 1 minus 2 times 1 over 2. So you get, let me erase this for a second. So if you simplify that, you get plus or minus the square root of 1 minus 2 times 1/2 is 1. You get plus or minus the square root of 0, which is just going to be 0. Let's pick 1/4. If you pick 1/4, better yet, let's pick 1/8. If you pick 1/8, what's going to happen? You put it in and you get plus or minus the square root of 1 minus 2 times 1/8. 2 times 1/8 is 1/4, so you get the square root plus or minus, because it has that plus or minus in front of it right there. So you get plus or minus 1 minus 1/4, which is plus or minus the square root of 3/4. Okay, just a minute. I've got a phone call coming in. I have a daughter that meets inside the school here. Just a minute. Okay, so when you take plus or minus the square root of 3/4, That means plus or minus the square root of 3 over the square root of 4, which is plus or minus radical 3 over 2. So if you were to put 1/8 in, you get radical 3 over 2. Also with 1/8, you get negative radical 3 over 2. The graph of this is something that looks like the following. There's the positive part of it. It comes over this direction, but you're also going to have the negative of it. And if you do the vertical line test, sketching a line in, it crosses at 2 points. So this is no. It does not define a function. All right, you had one more problem, which was 39. 39 is the cube root of x. And if we look at y being equal to the cube root of x, the cube root of x is also another parent function when you look at the graph of it. And the graph of it looks something like this. And if you were to do the vertical line test, yes, that does work. So the answer to this is yes, it is a function. If you want, you could pick values. You could say x and y. If x is -8, -2 times -2 times -2 is -8. You can take the cube root, the fifth root, the seventh root. You can take odd roots of negative numbers. You just cannot take the even roots. So this has a value of -8. If you talk about +8, the only number multiplied by itself 3 times to give you 8 is 2. So for every input, you're getting only one output. Therefore, yes, it does define a function. All right, let me stop this a second. Okay, so the next question is on 46, I believe, just part E. And 46 says f of x is equal to x squared minus 1 over the quantity x plus 4. You want part E, which says negative f of x. So if I want to calculate, it's the opposite of whatever f of x is. So I want the opposite, and f of x is x squared minus 1 over x plus 4. All you do is distribute that negative through the numerator. If you distribute it through both, you are looking at negative x squared minus 1 over negative x plus 4, and a negative over a negative is a positive, so you've not changed the problem. You've just factored out a negative out of the numerator and denominator. So now if I carry that negative sign through the numerator, you end up with negative x squared plus 1, that quantity over the quantity x plus 4. And there's your solution. Okay, the next question that you have is 58, and it says find the domain of each function. The domain is always the set of reals unless you have two things. The two things you have to be concerned with are a fraction, because you cannot divide by 0, and a square root, because you cannot take the square root of a negative number. So if you look at problem number 58, it says g of x is equal to the quantity x plus 4 over the quantity x cubed minus 4x. Do you have a square root? No. Do you have a denominator? Yes. And that denominator cannot equal 0. So we want to look at what makes that denominator 0. What are the values that make it 0? If I go to solve a cubic like this, what you need to do is first see if you can factor anything out. You can take an x out of both terms, which leaves you with x squared minus 4. If you look at x squared minus 4, that's the difference of perfect squares, and you can factor that again. And if you factor that again, that factors into just this part right here, factors into the quantity x plus 2 and the quantity x minus 2. The difference of perfect squares factors into its conjugates. So the highlighted region the quantity x plus 2, the quantity x minus 2 is just the factoring of that perfect square, difference of perfect squares of x minus 4. Now you're multiplying three numbers together in order to equal 0. So one of those factors, either x is equal to 0, x plus 2 is equal to 0, or x minus 2 has to equal 0. So your solution is x equals 0. If I subtract 2 from both sides, you get x is equal to negative 2. And if you add 2 to both sides, you get x is equal to 2. So if you look at it graphically, you have three critical points. You have negative 2, 0, and 2. We just found those. If you put negative 2 into the equation, you're going to get negative 2 cubed minus 4 times negative 2. Negative 2 cubed is negative 8 plus 8 gives you 0. You cannot divide by 0, so that ends up being an open circle. If it were closed, you could include it. If it's open, you cannot include it. If you put 0 in, you get 0 cubed minus 4 times 0, which is 0. You cannot divide by 0, so that does not work as your domain because you're going to get an error on your calculator. If you put 2 in, you're going to get 2 cubed minus 4 times 2, and it's just the reverse of signs. You're going to have 8 minus 8, which is 0 again, and that does not work. Now, looking at it graphically, you have three interval sets based off of those critical points. One interval set is in yellow, one is in green. Actually, you have four, sorry. One is in green, one is in blue, and the other one is in purple. If you pick values in each one of those interval sets, pick a value less than negative 2. So let's just go negative 3. If you put negative 3 into the problem, negative 3 plus 4, you're going to get 1 in the numerator. If you were to put it into the denominator, you are going to get negative 3 cubed minus 4 times negative 3. That's going to be negative 27 plus 12. You get negative 15. So you get negative 1/15. That works. So I hope you can see where that's negative 1/15 if you calculate it. You pick a value such as negative 1, and if you put negative 1 in the numerator, negative 1 plus 4 is 3. If you put negative 1 in the denominator, negative 1 cubed is negative 1. Negative 4 times negative 1 is positive 4. You get 3 over 3, which is 1. Yes, that provides you with a solution. If you put 1 in, you're going to get a solution. If you put a value over here in the purple interval, such as 3, that's going to give you a solution. So your domain, I'm not quite for sure how she wants you to write it. This is how I write it. Domain, x is an element of the reals, such that x cannot equal 0. I don't know if she allows you to put a comma plus or minus 2. If you have to put x cannot equal 0, x cannot equal 2, x cannot equal negative 2. I don't know if you have to separate it as x cannot equal 0, comma 2, comma negative 2. Not quite for sure how she wants it. The other way you can write it, I got to scroll down for this, is you could put it in set notation. That is set notation, never mind. You could put it in interval notation. Interval, you go from negative infinity to negative 2, use a parenthesis. If that were a closed circle and it worked, you would put a bracket. In union with negative 2 to 0, in union with 0 to 2, in union with 2 to infinity. So this shows your answer in interval notation. All right, if you have any other questions, let me know. I'll try working through some of the others and just emailing you the answers if that's what you need me to do, or I can record more for you. But right now I'm going to post this since it's already 20 minutes long. Love you.